has their hand up? Nobody else needs it printed? Okay. Alright, so we're graphing and classifying conic sections, so you guys are going to have to be able to write and graph an equation of a parabola with its vertex, hk, an equation of a circle, an ellipse, or hyperbola with its center at hk. You're going to classify the conic section, so you're going to be able to look at an equation and identify if it's a circle, a parabola, an ellipse, or a hyperbola. Do me a favor as I'm getting this printout right now. Everybody take a look at the standard forms of equations of conics. I went over the video with different types of conics and how we get them from a cone. We did a little activity with that. And now it's time to get right into all of these different equations. Right? Now, before I do a lot of those, I do want to spend a little bit of time on the quadratics as well, because for some of you guys that are still working on that Unit 2 test, it's quadratics and linear equations. A part of quadratics and factoring is going to be involved in this. So I want to make sure that you guys understand how to do factoring. The one thing that we're going to touch a little bit more on is called completing the square. I didn't really go over it, but you are going to have to be able to complete the square now, though. And it's not that difficult. Right? It's a simple thing. Okay? All right. So if you guys take a look at a circle, make sure that you guys keep in mind the center of a circle is at h comma k. All right. The radius of the circle is whatever this number is. If it says 14 squared, the radius is 14. If the radius said 9 here, but it didn't say 9 squared, then you have to take the square root of 9. So the radius would be 3. Okay. Parabolas, this is where we're going to do the completing the square. Okay. I'll teach you that. It's not that difficult. The vertex of a parabola is at h comma k. Right. An ellipse, the best way I can describe to you an ellipse is the way we rotate around the sun. Yeah. Hyperbolas, those are the parabolas, just two parabolas going in opposite directions. They could be going vertically opposite directions or horizontally opposite directions. Okay. All right. Now, some of the problems that we're going to practice are how to translate them. So it says, write an equation of the parabola whose vertex is at -2, 1, and whose focus is at -3, 1. So we're going to talk about some new terms too called focus or foci. We're also going to use those terms. Okay. Begin by sketching the parabola as shown. So first, the vertex is at -2, 1. So the h value is at -2. When you plug it in here, a -2 becomes a +2. And the k is a 1, so the k becomes y minus 1. All right. And the focus is at -3, 1. The distance between the focus and the vertex is the absolute value distance, how far these two apart. And that was 1 unit apart. And we're going to talk about how that evaluates, how that affects the equation. So these examples that you guys have here, this one is an example for a parabola. This is an example for a circle. Right. Now, in a circle, you guys have graphed circles before. Okay. And you guys understand that a circle of radius is the same distance all the way around. The equation for the circle, you're always going to keep in mind whatever the x value is squared plus whatever the y value is squared and equals whatever the number is. Notice right there it says 16. The radius is not 16, it's one number squared gives you 16. So do you understand it's 4 squared? So the radius on this one, 1, 2, 3, 4, 1, 2, 3, 4 vertically, 1, 2, 3, 4, and 1, 2, 3, 4. So when you guys are doing a circle, you got to keep in mind you need to know what the center is. If there's no x minus h there, it's because the h value is 0. If it just says x squared, and then it says plus y minus some number or y plus some number, okay, it's the x value is going to be a 0 then. And a 0 and a circle can be anywhere on the x and y axis. Okay. An ellipse. This one's going to be a little bit different because you guys notice the ellipse is kind of egg-shaped. So the radius is not perfect all the way around on an ellipse. Okay. So we're going to need to keep in mind we're going to talk about some terms called foci right here. Those are 2 points that are opposite the longer ends of the ellipse. Okay. One of the things that you're going to notice about the equation of an ellipse, it's always going to look just like a circle part of an equation, only it always has a denominator under the x values and the y values. Okay. The minute that does that, it's because it's stretching a little bit, either vertically or horizontally, depending on where the stretch is long. That's hopefully you'll notice that difference when we start working with problems, is that an ellipse is going to have denominators here, and a circle is going to look just like it, but without denominators. It's because the radius is constant all the way around. Okay. We always want to make sure that the equals, in an equation of a circle, it equals a number, and that number is, if it's not squared, we always want to keep the equals of 1. And this is why we're always going to get a denominator over here, because we always want that to be 1. So let's say instead of it was a 1, it was a 16, we would divide by 16 to both sides. Okay. Sometimes one of these terms is already going to have a denominator in it. Okay. So then you're going to have to remember a rule. What do you do when you do a fraction or a denominator divided by another fraction? You got to remember, change the division to multiplication and then flip a fraction. Okay. Hyperbolas. Hyperbolas are going to be a little bit different. You're going to have your parabola going up or down, but then you're going to have the reflection of it on the other side. Now, they're either going to both be going up or down, or they're both going to be going left or right. You're not going to have one going up and one going left or right. That's not going to happen on the hyperbola. Okay. If you guys notice, there's a minus sign right here. Okay. If you look at the previous ones, in an ellipse, the x's and the y's are being added. But in an ellipse, there's a denominator, yeah? Okay. You notice in the circle, the x's and the y's are being added, but there's no denominators there. And these are some of the things that you guys got to be able to start identifying, okay? So that way you can tell what kind of conic section you're on, yeah. The denominator will happen sometimes if we rewrite that value to be 1, right here on an ellipse. When we rewrite that value, that's when we're going to get these fractions down. Okay, so we'll practice with some problems so we can do that. Okay. And what we're going to eventually start looking at is, when we rewrite equations out of these examples, which one is it? Okay. And the thing that's going to be a little bit difficult is we can't use our calculator to just type it in like this. we have to get y by itself. So it gets kind of tricky to get y by itself. That's when you guys have to kind of have really good math skills, whether they're that simple of adding, subtracting, multiplying, dividing, and moving things to another side. Okay. So your math skills at this point are considered to be pretty darn good. You guys are in the point where you guys are going to start going into calculus, even though you don't know you're going to be going into calculus stuff right now. It'll be called pre-calculus. It still involves some of the trig functions. You guys remember SOHCAHTOA? Yeah. You did some pre-calculus already back in geometry. You just didn't know you were doing it. The only thing now is you're going to start to learn when we get a little bit more into it. After we get to hyperbolas, you're going to start to learn. We're actually going to graph sine, cosine, and tangent. Okay? All right. Circular models. Does this make sense? You guys ever seen the cell phone towers around here? What do they look like to you when you see them?
Oh no, that looks like a big tower.
A big tower. Does any of you see them and they look kind of like fake trees? You ever seen a tower and then it has all these things, but they're kind of covered in leaves, so it looks like it's a tree sometimes?
Yeah.
Those are cell phone towers too. You see a lot of those. And the cell phone towers, they have a radius, and the radius is wherever the tower, let's say I'm a tower, right? However far I can transmit is not going to be different in one direction than it is in the other direction, unless there's an obstruction there. For example, a mountain could obstruct. You guys ever notice when you guys go down the Cajon Pass, you might lose signals on your cell phone? Yeah? Okay. It's because sometimes cell phone towers are not able to go into certain sections of mountain ranges that are difficult to put towers on, first of all, if you think about it. Okay? All right. So it says a cellular phone transmission tower located 10 miles west and 5 miles north of your house has a range of 20 miles. One of the things that you guys got to keep in mind, cell phone towers, their range. Once their range is, then another cell phone tower is put after that, so that connection that you're getting is pretty constant, right? That's why there's a gap. So at some point down the Cajon Pass, if you notice, when you go down the Cajon Pass, you've got the McDonald's off the freeway. Typically, you'll have connection up to that point, and then you'll lose it a little bit as you start to get down to DeVore, where the 15 and the 215 split again. And that's usually because there's nothing there. And you guys realize too, the mountain range is kind of bumpy. So typically, it'll reconnect and you'll get signal again once you're right back down that 215, 15 split. Okay. Inequalities, remember inequalities can always compare something two different ways. The easiest example I give people is if you're taller than somebody, if you were to say, I'm taller than you, you're actually saying two things. You're also telling the other person that they're shorter than you. Does that make sense? With inequalities? And remember, you got greater than or equal to and less than or equal to. All right. And those inequalities are going to be when we start shading in parts of the circle. So if you don't remember when you guys used to graph inequalities that said y is less than or equal to 2x squared plus 3, how did you know if you shaded the top or the bottom of the line? The easiest trick I showed people was plug in 0, 0 for x and y. If it reads true after you simplify it, then you shade that part of the section. If it's false, then it's the outside of it. Okay? And again, we're going to practice this stuff. But one of the things you got to keep in mind, if you get stuck and you're like, okay, which equation does this look like? Go back to some of these examples. Okay. All right. Most of the problems that we're going to deal with in the conics section are all in the second degree. Now remember how in Unit 1 test you guys learned how to find the equation of a parabola pretty much by just using the input-output table? That's a pretty good skill. And you guys at first didn't see it, but now you guys started seeing there's patterns in the input-output tables. Okay? All right, now this is something that is very important. Put a star here in your notes on this, classifying by the discriminant. However the graph is laid out, if b squared minus 4ac is less than 0, b is equal to 0 and a is equal to c, that means we are looking at a circle. Okay? If b squared minus 4ac is less than 0 and either b is not 0 or a is not equal to c, then we're looking at an ellipse. So this gets kind of tricky. You're gonna have to go back to this rule. Now you guys remember how do we identify a, b, and c on a problem? Ax squared plus bx plus c. So if you don't remember, do me a favor. Ax squared plus bxy plus cy plus dx plus ey plus f equals 0. Remember that equals 0 is the same as saying equals f of x or equals just y. Remember that 0 is still represents that. Okay. Now these are the 4 different types of conic sections, and each one of them, if b squared minus 4ac is greater than 0, then we've got a hyperbola. Now the fact that you can identify it, that's great, but then you're going to have to be able to graph it as well. Okay? So not only by doing this are you going to be able to identify the 4 different ones, but you're going to have to be able to graph them as well. Everybody okay with y equals mx plus b kind of graph equations that are in y equals mx plus b? Yeah? Okay. Remember, this is your y-intercept. M is your slope, so go to the y-axis at whatever the value is right there, and then go up or down and over to the right, however that m says. Yep. And then you guys got into these, y equals ax squared plus bx plus c. Those were the parabolas. If a was positive, parabola was going up. If a was negative, parabola was going down. The c value was your y-intercept. Don't forget, to get y-intercepts and x-intercepts, it's still the same rule. To get the y-intercept, let x equal 0. Okay? So to get y-intercept, let x equal 0, right? To get the x-intercepts, what do? Let y. So you just remember that you just switch those with each other. Okay. This one is very important because in the last test, in the Unit 2 test that you guys haven't finished, some of the questions said, what are the solutions, what are the roots, what are the zeros, what are the x-intercepts? It was, where does the graph cross the x-axis? And it's okay if you type it in onto the graphic calculator, that's what it's there for, but you guys realize sometimes the numbers are going to be decimals, and you have to give me exact values, whether they're written as a fraction or not. And that's when I told you guys, if you have a quadratic, ax squared plus bx plus c, if the bx term is missing, it's not there, the b value is 0, all you got to do is minus c to both sides, and you'll get ax squared equal to that. Divide by a, where if that's a positive or a negative. If a is a negative over a negative would make it a positive. Yeah? And then you would do the square root. if you have a number inside that square root after it's simplified and it's negative, that means that what? Can't use square roots and negatives. As we move on, though, I'm going to teach you there's actually numbers that are square roots of negatives. They're just called imaginary numbers. I don't know if I've ever said that to you guys enough. Okay? You're going to start working with imaginary numbers. These are numbers that don't exist. It's kind of like ghosts. But it's kind of weird because when people die, where do they go? They lived at one point, they did. Right? So I mean, we're all going to eventually die. We're not going to live forever. So I'm hoping that when I do die, hopefully not today or anytime soon, that I do go somewhere. I don't know. I don't know. Nobody's that week. I don't know anybody that's told me they had somebody come back and tell them what happens after. Here's something for the best. All right, so that's if the bx term is 0, right? You understand? You can solve that pretty easily. You don't have to do the Xbox method. Yeah, just go right into solving it like a regular equation. If it's not like that, make sure you guys are taking good notes. If it's actually, if you know what the A, B, and C value is, for somebody that might have forgot what to do, how to do the Xbox method, you have to do the AX squared term times the C term on the top of the X. Okay, Sandra?
Is there another way to do it, like to factor them?
Yeah, there's several ways we can do it. I'm gonna start always with the X though, because if the A value is 1, all you need to do is figure out two numbers that multiply to give you the top, but add to give you the bottom. Whatever those numbers are, you can already factor it into the parentheses right away if the A value is 1. Yeah. If it's not 1, it gets a little bit tricky because you got to look at different combinations of numbers that will work, and sometimes it's not that easy. You kind of have to play with the numbers in your head or actually write them out to see which ones do work. Because sometimes you guys have so much going on, it's hard to keep track of everything in your head. Okay? And I always tell everybody, just don't do it in your head, just do it on the paper. Okay? That way you don't lose track of where everything is going. Okay? If the A value is 1, you can go from here pretty much right to here. Okay. We'll take a look at some of the examples that are going to be in the handout. Okay. If the A value is 1. Okay. If the A value is not 1 and you're having trouble figuring out those two parentheses to factor it right away, that's why our suggestion is just get to the X first. If you can't figure out two numbers that multiply to give you the top but add to give you the bottom, remember I showed you guys how to use the quadratic equation? If you forget the quadratic equation, it's x equals negative b plus or minus square root of b squared minus 4ac, all of it over 2a. You should have that written down somewhere. If not, I would rewrite it again. Okay. Over there. Remember, there's two answers in here. But if the b squared minus 4ac value is 0, square root of 0 is 0. So you're just going to get one answer. If the b squared minus 4ac value is a negative number, no solutions because you can't do square roots of negative numbers. Yeah. If the b squared minus 4ac value is a value that's 1 or bigger, there's two answers. This b squared minus 4ac is called the discriminant. Okay? That's what it will be referred to. Check the discriminant. Okay? Check the discriminant. Can you factor it or not? If you can't factor it,
Then, in this unit, you're going to be asked to still write the equation of it, which means you have to factor it by force. So how do I factor it by force? That's when I show you how to do what is called completing the square. I'm going to make this work no matter what. So we can force factor stuff. We just have to remember whatever we do to one side, we have to do it to the other side of an equation. If we're going to force it, that's the one thing about math that you're always going to realize. You can't just do one thing to one side, but not to the other side. It doesn't work out that way with math. You have to do the same to both sides. Okay? So when I teach you how to, it's called completing the square, but really I'm force factoring something that's not supposed to be factored, but it's because I want to write the equation. That's why I'm going to do it. We force things all over the place. There's always, I don't know if you guys have been seeing the skies, but those chemtrails are popping up everywhere. You guys see the thunder last night? Yeah. It was crazy. It was crazy. I videotaped 10 minutes of it.
I was sleeping out.
It was about, I think it started before 2 o'clock in the morning, because I think I woke up at 2:30, 2:40 or something, and I started recording. And then I got some great stuff in my battery, my memory built up. The reason why I'm bringing it up is because, I'm talking about force factoring something. I am forcing something into the math. We're always being forced to do things. I'm trying to force you guys to hurry up and finish the unit 2 so I can get it in. There's only a certain amount of force I can actually do, though. You're not going to believe I can do it. But it benefits you if you get this unit in. Yeah. So, there's times you'll think that I'm like, I'm so mean. I'm like, if you were to get the unit in, get that taken care of, I wouldn't be that great to you. It's just because the quicker we can get through these units, the better it is for you. I want to finish before Thanksgiving. And I don't want to come back after Thanksgiving, because we're actually going to have that whole week off. I want to be done.
Wait, done with all 5?
Mm-hmm. It's all fun. My geometry, we're already on unit 4. Which is fine. You guys are still okay. You're doing good. But just keep in mind that things are always going to be forced on us. And sometimes we just have to suck it up and just get through it. Okay? When you do the Xbox, so for some of you that haven't finished, remember to factor it, it's ax squared times the c's on the top. The bx is on the bottom. After you do this, what I tell everybody to do is, once you figured out what the 2 question marks were, then write ax squared plus your question mark x. It has to have the x in it, because x times x gives you the x squared, right? Plus whatever the other question mark is, and those 2, remember, it doesn't matter which one goes first and which one goes second. And then plus your c value. Group these 2 and factor out what they have in common. They should have at least an x in common, which will leave you with ax plus the question mark, but then the question mark and the a value might have something in common too. Yeah? And then you gotta remember to do this. Plus whatever these 2 have in common. And typically it's going to be the question mark and C that'll have something in common that you take out. So there's going to be something here. It could be a 1 if nothing is there. And then what you got to pay attention to is this parentheses and this parentheses the same. And that's what they typically will be. They will be identical. So whatever's left is 1 parentheses. And the other parentheses should be these 2, and now it's factored. And remember, how do you find the zeros of the roots, or the roots of the parentheses? Just set the parenthesis equals to 0 and solve for the variable. So for some of you that are struggling with that unit 2 problems, this is what you're doing. So you might have forgotten that for whatever reason. You also have the quadratic. Quadratic's going to do the same thing. It'll just get you right to the answers right away. If you do the factoring like this, you still got to set each parenthesis equal to 0. Okay? So what I'm going to do is, we're going to get stuck right here. So we're going to force the factoring to get these 2 parentheses, because I want to be able to write the equations of one of those 4 types of graphs, whether it's the circle, the ellipse, hyperbola, or the parabola. Okay, so that's what I'm going to do, completing the square. And it's a fun activity. It's actually kind of like a game. Okay. The only thing is I don't have enough of the toys, so we'll have to draw it out. Okay. All right. So you guys see this part of my notes right here? Because this is kind of some of you guys might be struggling with that in that quiz that you guys have finished, okay? All right. Don't forget x-intercept and y-intercept. Still same thing, just let x equals 0 to get the y-intercept. Let y equals 0 to get the x-intercept, okay? And don't forget this part, 0. If everything is equal to 0, then you're saying, as long as none of these are x's and y's, but do you see there's a y in there? So that means now we're going to, unless it's just a parabola, ax squared plus bx plus c, that means f of x, y, right? But now if you notice we have x and y on the same side of the equal sign there. When they're equal to 0, they're just equal to that number now. Okay? All right. So now let's go ahead and continue on. It's really important that I take my time right now on this, because this section can get tricky. That's why when I first did the video, I want you to understand why, where did they come with this section in geometry, first of all? You understood how they did the slices and stuff? Yeah? All right, and all the examples that I'm kind of skipping over is because they're for you guys to be able to go back and use as a reference. Okay. All right, so classifying a conic, which means we're going to look at a problem. We're going to take the A, the B, and the C value. And remember that part I told you you're going to have to start. We're going to have to go back to this. We're going to go back to this section. Okay. We're going to have to determine which one of these 4 it is. Okay. So if you look at examples that are here, what we're going to end up doing is, how are we going to go from this to this? This is the main thing. How are you guys going to get from there to that equation? Okay. Now in this example, for example, this first ellipse, do you notice that we had x squared and y squared together? Do you notice that the equal sign, I always tell my algebra students, always put the line where the equal sign is, so where you know the left side of the equal sign and the right side of the equal sign. Anything that's on the same side, you can rearrange it however you want, as long as you follow the rules of adding, subtracting, multiplying, and dividing. You got to keep the stuff the same sign. Okay. Do you notice then that we moved this negative 4x and this 2x squared together? It's still a positive 2x and it's still a negative 4x. They're still on the left side. And you notice the y squared just got bumped over to this side. How did this 4 get there? How'd that 4 get to the other side? Canceled the 4 by adding it to both sides. Okay, that step's not shown because it's assumed already that you understand how to move things. Okay. I don't play video games. Do any of you guys play video games? No? Okay. So we're all because I don't know how to play a video game. I mean, you put me in front of a old video game, Mario Brothers, that's two-dimensional. It just, I can go jump up or down and go left or right. You know, I know up and down, left and right, you know. You put me in the one where you have the box, I'm just gonna push all the buttons to see what happens. So, now you have to know how to move things. You know, eventually we're gonna get into 3 dimensions. You know the x-axis, right? You know the y-axis, but then there's another axis called the z-axis. That's how video games started to move. Before, if any of you remember, video games were 2-dimensional. You know, Atari, Super Mario Brothers, Pac-Man, all those were all 2 dimensions because they were just using the x-axis and the y-axis. Once they learned how to implement X, Y, and Z, now our video games look like movies to me. I see a person playing a video game and I'm thinking I'm watching a movie. You know, video games are so huge now you can make big money and you become a big gamer where you know how to play the game really well. I mean, there's people that watch video games more than they watch the Super Bowl. Just in the last championship tournament that they had, more people watched these people playing a video game than people watched the actual Super Bowl. You know, some of those people make good money, but I'm like, those people spend all day on a video game. You know, I can't do that. It's too much. Too much. I want to be outside. Yeah. All right, so we're going to have to make sure that we can rearrange things, okay? So the reason why I'm going so slow is because it does take a little bit of time to get to be able to do this, okay? After I rearrange it, I get the GCF of those 2 terms, and then there's a question mark in there. That question mark is, now I'm going to force factor this, because I can't figure out x squared minus 2x with what. I'm going to force factor by doing what is called the completing the square. Remember, whatever I do to one side, I have to do it to the other side. And this is where things get tricky. All stuff is happening, all this stuff is happening, and you got to keep track of it. So this is where it becomes critical. You got to write your steps out little by little. Okay? After that, then somehow we magically get to this equation. Once we get to that equation, the denominators are there. Remember I told you denominators are going to tell us if it's an index. And the value over here had to be 1. Okay? If we try to multiply everything by the common denominator and get the denominator out of the way, then we'll have a number way over here. So this is the key thing. It gets tricky. So I gotta take my time right now so you guys see some examples so you can go back to, okay? Does anybody have a question right now just by looking at that example? Is there anything that kind of throws you off right now?
Now I get the 3 and the 6.
All right. How did you get the 3 and the 6? It looks a little, they don't show this step, but I'm going to erase a little bit of stuff here so I can give you that. All right, so from here to there, they kind of lost you, yeah? Just remember your simple skills in algebra. Whatever you guys learned in algebra, I'm so tough on my algebra students because if you don't get that foundation from there, everything else becomes different, okay? What they did was a basic skill that I taught you guys, or we learned in algebra. How do you, I want to get this side over here where there's a 6, I want it to become a 1. What if it would have been a -6? Didn't matter. You guys agree 6 divided by 6 is 1? But whatever you do to one side, you got to do it to the other side, yeah? You notice y squared over 6 is not going to reduce at all. Plus, this is all one term right here. You notice the 2 is on the outside of the parentheses? That 2 and that 6 can reduce. That's why that 3 is there. Does that make sense? Okay. And this is why I need to go slow, so you can ask me some questions on, okay, I don't know where this, how did you get this number? Actually, no, it's just you've never done it. Once you do it once, you'll start to look for it. Yeah? Okay. Same thing why I'm always telling you guys about things, because you got to look for stuff. There's stuff that you don't pay attention to. And I tell it to you because I'm like, I'm 44. Some people would have told me that at my age, when I was like you, things would be different. You would question things. Question things, always. Okay? Don't believe what I say. And remember, there isn't just one way to do things. There's different ways. As long as you can show me how you did it, though, that's the main thing. Is let me see your reasoning. Okay? If you can ever prove this, 0 divided by 2 is 0, okay? It's numerator always goes inside. That's one of the rules that some algebra kids always mess up, because they always want the bigger number inside. And yeah, when you guys did that in elementary, that's why division was easy. Yeah? 0 divided by any number is always going to be 0. 2 divided by 0, 2 goes inside, 0 goes on the outside. That's different. This mark that I make here means what? No solution, doesn't work, undefined, you can't do this. You're never going to do this. If you ever figure out a way to do this, people are going to wonder how, and if you can prove it, that it doesn't become undefined, that it actually represents something, you're just going to blow the mind of every person in history. You know, and this is where your mind comes into play. How good can you control things in your mind to play with them? Math is just a bunch of numbers, okay? And it's these 4 things basically. The rules of exponents are multiplication. Yeah. Okay. So do you guys, that question that you asked me, where did the 3 and the 6 come in those denominators? It's because we wanted to get this to become a 1, because if it's a 1, now I can see the ellipse part of it. Yeah. Anything else in there that looked kind of weird to you? Now none of you guys are asking me about this. Say it again, something? Why did they put a 1? Why did we get a 1?
Why did they put a 1 for the question mark?
Oh, okay. Why did they put a 1 for the question mark? Good question. This is the key to forcing the factor. This is where I needed you guys to ask me about this. Okay, but I need you guys. You've ever heard the reasoning of you can't lead a horse to water and make him drink. You can lead the horse to the water, right? You can't make them drink. If they're not thirsty, it's just going to be there. And if it doesn't drink ever, then yeah, it's going to die. So I can't always make everything so easy for you. I gotta not force things, but I gotta make you think. Because once you start using your brain, that is a muscle. And sometimes it does hurt to think, but it's okay. Your muscle can get strong the way your muscles can get strong, like with weights and stuff. The more you use your muscle in your brain, the easier it is for you to process things, and you guys start learning to make better decisions. Okay. Just I gotta be careful what I say. All right. So where did that 1 come from, right, Sandra? Do you notice that this was 2x squared minus 4x right there? And that 4 was there, but that 4 I didn't want to use it. So it was moved to the other side because I wanted to get just the y's there. And I wanted to get these x's alone. Now, do you notice that they factored out a 2 from the 2x squared minus the 4x? If you were to multiply that 2 back in, you'll get the 2x squared minus the 4x, right? Well, they did that because they want the a value to be 1 inside the parentheses. And this is where completing the square comes in. If the a value is 1, you can complete the square, or you can force the factor, okay? All you gotta do is, this question mark becomes b divided by 2 squared. I'm gonna teach it to you, okay? But you're like, b divided by 2 squared. Where did you get that from? Well, that's part of like the rule of completing the square, okay? So when I complete the square, you're like, why did they even call it complete the square? It's like, I honestly, when I first got introduced to it, I was like, complete the square. When I was in calculus, and, I was doing pretty good, but I was like, complete the square. It doesn't make sense to me. It's like somebody was speaking another language, which math is another language. You guys are speaking another language, okay? It was funny, when I was in college, and I was taking physics, I was having trouble with some physics stuff, and my professor was separate from my lab instructor. My lab instructor was this guy straight out of Russia. He used to work with intercontinental ballistic missiles in Russia. But he knew English, but he didn't know the manners of being in the United States. Totally different thing. The guy was in a structure for like 10 years underground, and then he decided to come to the United States. I taught him some mannerisms of America, and he taught me that. Some math stuff that I wasn't understanding. Because to him, the equations to make missiles was like he saw showing kids. It was nothing. But that was his job, to make missiles. Missiles that can go anywhere to London and go like this. So he taught me some stuff, and I was like, oh man, it didn't make sense to me, but little by little, it took time. So that's what's going to happen here. It's going to take you a little bit of time to get used to the b divided by 2 squared. Okay. Here is ax squared plus bx plus c. I'm going to erase this stuff that I wrote. Do you see it? A is 1 in the parentheses. B is a -2. And C, I don't know what it is, right? We'll do b divided by 2. B is a -2, right? Well, -2 divided by 2, -1, but remember, -1 squared is, that's where that one came from. And here's the other thing, whatever you do one side, you gotta do it to the other. This is why I love math so much. I know things happen to us and we're forced stuff on us, but eventually, Mother Nature, you can't control Mother Nature. I've never seen a storm like last night. I'm not gonna lie, for 44 years. I lived in Arizona. When I was going to school, seen monsoons. I lived in Mexico, where I've been in earthquakes, and in California, when there used to be earthquakes. There hasn't been any earthquakes in California like the ones we had in the 80s. We had some earthquakes where I remember being little, and just stuff was shaking everywhere. In class, I haven't seen those type of earthquakes in California, in Mexico too. And I have never seen the lightning and the thundering the way I did last night. You guys You guys saw it, right? Or you guys heard it, right? Yeah.
Oh,
Did you guys slept through it pretty good? Pretty deep sleep?
it woke me up actually.
Yeah. I videotaped it. I'll try to show it to you. It's hard because it's almost 3 in the morning. I got 10 minutes of videotape because that's as much memory as I have on my phone. So does this make sense where the 1 came from? But do you notice I put a +1 here? I have to put a +1 on the other side. I cannot do things unbalanced in that. If not, something is wrong. Okay. 2 times 1. Now, do you see that this 2 over here is this factoring of 2 over here? Whatever I did on this side to make myself force factor it, I have to make sure I keep track of it on the other side, because if I forget that +2 times that number I don't know, this never becomes a 6, it stays as a 4. And if it stays as a 4, this ellipse becomes something different. It doesn't become the same ellipse anymore. Okay? So this completing the square part, this is really just what it is, completing the square. B divided by 2 is squared, but you got to do it to both sides. When you do that, do you guys agree that x squared minus 2x plus 1 is x minus 1 times x minus 1? If you do the full method of it. And I'll show you when we practice it, okay? I do want to talk about this word.
I have a shot of your apple cider vinegar.
Oh, it's over there in the, did Bethany tell you?
No, I saw it.
Oh,
And I'm like, I do it.
yeah, I got some juice too. Yeah. All right. What was I saying? So now when you look at this, all this work, I don't think it's a lot of work. I think it's knowing how to play the video game. That is, but you know how to play the video game. You've learned it. That's why in algebra you got the basic. Geometry, you got to see other stuff. It was all that stuff. How all the things that are going to affect us. Okay. We're going to play a little game called completing the square. Okay. That completing the square, it seems weird. How do you complete the square? So I have to teach you the game, how to play it. Okay. All right. So before I do that, though, let's keep going on here. Here's another example. Now, if you look at it, it says 4x squared plus minus 9y squared plus 32x minus 144y minus 548 equals 0. Everybody on this, can everybody have this example in your notes? Yeah? You don't have that one? Check and make sure. It should be in there. Example 7?
Oh, yeah.
Yes? Okay, got it, got it. Got it? Yeah. Christine, you got it? Yeah? Sandra, you got it? And, okay, all right. Now, do you notice the problem looks pretty similar to the way the last one just started, as an example? Everything's equal to 0. Take a look at what happened from the first step to the second step. You guys notice what's happening there? Can anybody describe to me what happened from, let's number these. This is step 1, step 2, step 3, 4, 5, 6, and 6 would be when you got to the end. Okay. Can anybody describe to me in words, what do you notice from 1 to 2, DeAndre?
They use grouping to group the x's together in the ones and to cancel the 548 to one side to the other by adding it.
Okay, perfect. That's, hopefully everybody noticed that. That's one of the things we're going to have to do is group things. Okay, we've got to group things together. All x's, all y's. Get the number that's a constant, move it to the other side. Okay? We did that on the last exam. Yeah. All right, look from step 2 to 3. Look at what happened from 2 to 3. So that's what they're doing with it. What do you notice? What do you think happens?
Oh, they're taking out. I don't know. He's got the floor.
And that's called the GCF. They're doing the GCF of these two. They both have 4 in them. Everybody agree? Multiplication is the inverse of division. So when you multiply by 4, you should get 4 back, 4x squared. 4 times 8x is the 32x. Yeah. That's called creating the GCF, the greatest common factor. What do they have in common? Okay. And you see in the other parentheses, the GCF was a negative 9. You distribute it back in, you get what you started with. If you can't go backwards from what you did, something's wrong. Does that make sense? If you cannot go backwards, if you can't distribute it back in and get what you had originally, something's not right. You didn't do the GCF correctly. Yeah. All right. So now we're to the question mark again. Do you see that that value that they're getting? That's where the letter is square. They're trying to make that a 1. They're trying to. We need you. I need you to remember. We're trying to get that to become a 1. Some way we're going to force it, because once I do that, then I'm going to do this. So b divided by 2 squared. So now, that's the b value only in the parentheses. 8. 8 divided by 2? 4. 4 squared? Okay, do you see the 16 on the other side? All right. Now this is x squared plus 8x plus 16, right? Remember, for those of you that are still struggling in that last unit test, ax squared plus bx is the top of the x, so that's really 16x squared, right? And bx is the bottom, right? 2 numbers that multiply to give you the top, but add to give you the bottom. 4x and 4x. If the a value is 1, x plus 4x, I'm sorry, x plus 4 times x plus 4. And do you agree that's the same as saying x plus 4 squared?
Yeah.
And do you see that that's what they got right there? Yeah? Okay. The completing the square is just a fancy term for forcing something that wasn't there now. But now that it's there, do you see how easy it becomes to factor it? The thing that you have to be, you guys are going to have to be like surgeons. You're cutting things up. You got to keep track, because imagine they're having surgery on you right now. And let's say they're trying to get to your heart. They got to cut the skin here. Got to cut your chest open, right? Whatever stuff is in between, they got to start moving it out so they can get to the heart to pull it out, right? And then they got to get the new heart back in. They got to put everything back together, exactly the way it was. Yeah. So that's how you're kind of looking at this. You're performing surgery on this problem. So you got to make sure you keep track of everything as you're opening it up. If you lose track of something, that's where the problems are going to, your answers are going to be off. Okay? Because if you forget this 4 over here, that throws the other side off, which is going to change your type of graph at the very end. Just that. You do that, you forget that, now you've totally changed the problem again. You've got to keep track of everything. Whatever you do to one side, you've got to do it to the other side. If you don't do that, you're not following the rules fairly. Okay? Which is going to cause the problem to go up. Okay. From step 1 to 2, you guys see what happened? Yeah, okay. From step 2 to 3, you understand? They got the GCF, they already did the GCF, now the value of A became a 1. That makes it way easier to force factor. Now I just have to find the D divided by 2.
Okay, so for the blue question mark, you do the same.
That's the same thing, only 16. Does everybody see that the blue question mark and the red question mark, it's two separate forcings that you're doing? You're force factoring it, but two separate things, but you gotta keep track of those two separately, yeah? Over here on this one, the B value is 16, right? 16 divided by 2 is 8. 8 squared is, so you see where the 64 is coming from? Does that make sense? Yeah, okay. Remember, you're performing surgery, you're cutting things open. You gotta make sure you can put things back. If you can see that, you can go backwards the same way, then everything should be working good. Eventually, you're just gonna get right back to here. When you get there, you already know that this has a value of 1. There's denominators here. Those denominators are telling us this is an ellipse, not a circle. It's a minus. That's going to be a big difference. The center of this is at -4, -8. That's where the center of this figure is. Okay. To get from 3 to 4, so are you guys all okay how to get from 3 to 4?
Mm-hmm.
And the beauty about completing the square is when you figure out those 2 on the side, that the parentheses is x plus that number and that number. They should be identical. Because you're forcing something, you're trying to make it perfect. Okay? So that's why these parentheses become so easy. Now the next part is, does everybody see that the 36 became a 1? Right, you divided 36 divided by 36 is where the 1 now comes, right? But over here, -9 over 36, when you reduce it, nothing stays on the top. 9 goes into 36 4 times. 4 is the same as saying 2 squared. Does that make sense? Okay. Over here, 36, that's 4 over 36. Simplify that, that'll give you a 1 over 9, right? But is it 9 the same as saying 3 squared?
Can you put either one? Could you put a 9 instead of just?
You can put a 9 there, and the thing is these are gonna tell us how far is it. Remember, one of them is longer than the other one, remember?
Oh, okay.
Because it's an ellipse, it's egg-shaped. If it was a circle, then these 2 denominators would be identical. We just multiply them and put them over here on this side. If the 2 denominators are identical. Yeah. Okay. But right now, remember, we're just learning how to play the game. So we just gotta kind of see somebody play, basically. Yeah. Okay. Once you start learning that, then you guys start realizing, okay, I can do this, I can do that. And you start manipulating it on your own. Okay? That's not the only way you can manipulate it, but this is the most efficient and quick way to do that by doing completing the square. Okay? It's not the only way. Okay? So just keep that in mind. This isn't the only way to do these problems. Okay? All right. So you got another example here. Right? And all these examples, oops. Now, if we're going to be asked to determine is it a circle, an ellipse, a hyperbola, or a parabola, we're going to, all we need to do is check the discriminant, the b squared minus 4ac part. Yeah? You notice that the b squared minus 4ac part is in the quadratic equation, or the solving for the quadratic equation is the square root part. Yeah? Okay. All right. Now, is this in your notes, right? Is that page in your notes? No? Oh, okay. You don't have it? Okay, that's fine. Yours has it? Oh, okay, it's good.
It's there, it's just on the page.
Oh, it is on, it is there, right? Okay. Yeah. All right, so we want to be able to go through these types of problems and identify if it's, explain why circles, ellipses, parabolas, and hyperbolas are called conic sections. Okay. The conic sections derive from the cones and the different types of cuts you could do on a cone. That's where those came from. How are the graphs of x squared plus y squared equal 25 and x minus 1 squared plus y plus 2 squared equal 25 alike? For number 2, what do you guys notice about the two equations? For number 2. You guys want to do something interesting? Do you think we can type that into the graphic calculator? Not like that. Can't type it like that. Y needs to be by itself. Could you rewrite it to make y by itself?
Yeah.
That one's pretty easy. This one over here requires you to do way more stuff. Let's look at this one. If I want to get y by itself, what would you move first? You'd move the x squared. And you guys agree that you would take that x squared away? Yeah? Okay. That'll give you y squared equal to 25 minus x squared. You could have wrote the negative x squared first and then plus 25. Yeah. Could I type that into the calculator right now? Square root. Y is equal to the square root of 25 minus x squared. We can type that into the graphical calculator. Let's get your graphical calculators. All right, so let's type in our calculator. So y equals, all right. We're going to type in y equals square root of 25 minus x squared. You go ahead and type it first. See what you come up with. You got the graph of it? So I'm going to go ahead and let's go right there. Square root of 25 minus x squared. Yeah. There's only one thing missing that we forgot. It's up here. There's only one thing missing in that answer to make it completely correct. Give you a hint, we get the square roots involved. Supply it. Okay, maybe.
Like 55, yeah.
It's actually a lot easier than you think. For example, to get the area of something, you do the length times the width, yes? Okay. So let's say I tell you that it's a square. In a square, all sides are Equal, right? Okay. If the area is 16, what's the length and the width? 4 and 4. But in math, though, 4 times 4 is 16, but something else is 16. That's
4 squared.
Isn't negative 4 times negative 4 16? Here's what's missing. Plus or minus. Remember back in algebra when you had to do the plus or minus and the square root thing? So the only thing missing in our equation is we just graphed the plus square root of 25 minus x squared. We need to graph the minus of that. You guys agree? That was taught to you, the plus or minus of the square root? Yeah? Okay. So now we have to finish it, and we need the other half of that graph drawn. So we need the minus, so you got to use the button below the 3 as the minus, and do the square root of 25 minus x squared now. Oops. Minus x squared. And I need to delete that one. Okay, so that should graph it. If you ever get these types of things, go down to the 2 part where it says go to, because it'll take you to where the error is. So go to, okay, I can get out of the square root. What I can do is I can put a 1 there.
You don't have to.
No. All right. So that's the only reason why something was off right there, because it was saying, well, you said you were going to put something there, but you didn't. Yeah. So I had to get out of it. Does everybody get that figure now, Greg? Yeah. Is that a circle? Doesn't look like a circle. But I can count. Everybody agree the center is right there at 0, 0? Yeah? Count. 1, 2, 3, 4, 5. That's 5 units for that radius, right? Are all of them 5?
Yeah.
That one's 5. And that one's 5 also. So this does have a radius of 5. And the center is at, oops, center is at 0, 0, right? So that means x minus 0 squared plus y minus 0 squared equal to 5 squared. Is that the same equation as x squared plus y squared equals 25?
Yeah.
Yeah, same thing. And remember at the beginning of the class today, we were telling you that h comma k value is the center of the circle. The number, if it's not squared, you do the square root of it. Square root of 25 is 5. But in this case, really, it's plus or minus 5, because 5 one way from the center and minus 5 the other way from the center. Yeah? Everybody okay right there? Yeah? Now, do you see that the other one, we have to do the FOIL method to each parentheses, x minus 1 squared. And then we have to do the plus y plus 2 squared FOIL method there, and then get y completely alone. That one would get very messy to get y alone. So why do we have to learn how to complete the square so we can get to that equation a lot easier? Okay. Now there are going to be some cool functions on these calculators that we're going to be able to use. Right? Everybody okay with the graph of our circle? Yeah. All right, so now if you kind of think about it, a lot of this stuff is always going to come back to just plain simple math. Okay? So let's just check to make sure we're good. How can the discriminant b squared minus 4ac be used to classify the graph? Right here, so does everybody understand that? That's why I had you guys put a star by that on the notes at the beginning. That's going to help you determine circle, ellipse, parabola, or hyperbole. Those are the four. Yeah. A circle with a center at 4, -1 and a radius of 7. Could you write the equation of this if you know that information? Do you think you guys can write it? You want to do it together? Yeah? So do me a favor then. Go back to the first page. Go back to the first page. Find circle. Find circle. So circles say x minus h squared plus y minus a squared equals r squared. Is that correct? Yeah? Okay. So, I need you to remember that, okay? Remember that the center of the circle is at h, comma, k, which I know already, don't I? And the radius is r. I'm going to erase this in a second because we're just going to write the equation of it, okay? So again, you guys see, you got to go back to that first page. All right. The equation of the circle is x Okay, see if you can fill in the boxes with the information. Okay, I'll give you a minute.